Okay, so we have this differential equation, a bunch of different letters that we can quickly solve for. A is the amount of gallons of saline added to the aquarium per minute. So it says they're adding this mixture at a rate of 10 gallons per minute, but A isn't 10 because A is specifically the amount of saline added, and it says it's 60% saline. So A is 6. I'm just going to use y prime for dy dt. Excuse me. D is the amount of solution draining, and it says it's draining at a rate of 6 gallons per minute. So R is the amount of solution out of the aquarium per minute. That's not saying it's just saline, that's both 40% water and 60% saline. So it's a total of 10 per minute. So 10 minus that 6 gives us 4 T, and then K is the starting amount. It starts with 140 gallons. And then this is all times the amount, what was Y again? The amount of gallons in the mixture, I think. Okay, so this is a first order linear differential equation. We can separate it. So the standard form is you have your y prime term without a coefficient. You have the term that involves y to the first power. So I'm adding that to both sides. And then on the right would be terms with just t in them, but this 6 doesn't have a t. That's okay. That can still be considered a function of t, just t is to the 0 power there. So to proceed, you could find your integration factor, multiply it to everything in the first order linear differential equation, or you could use the formula the textbook derives. So I think in the other videos I've just gone straight to the formula. You can use notes on my tests, so if this is the approach you're comfortable with, that's perfectly okay. Okay, so plugging right into the formula, this is the function that's multiplying to our y variable. So this is the integral, negative integral of 6 over 4t plus 140. It's times the integral of e to the power of the integral of 6 over 4t plus 140 dt times f of t, which is just a constant 6, so I'll just factor that out right now. No way, I can't because of the plus constant c, so 6 goes here. That'd just be another arbitrary constant, so it doesn't matter. You could factor out that c. Okay, so this, let's see, 4t plus 140 can divide 4 out of both of those. So that's 6 over 4 once I factor it out. In other words, 3 halves. That's going to be 35, I think I remember, because I tried this earlier. And then in here, we're taking the integral of 6 times e to the same result, just positive instead of negative. So I'm not going to draw that out again just to save myself a little bit. Okay, so this is like 1 over u. The integral of 1 over u would be natural log, right? So this is e to the power of negative 3 halves times natural log t plus 35 times the integral of 6 times the e to the positive 3 halves, because it's the same integral, and then it's the same integral in the exponent, just different signs. Okay, so that simplifies. This is a coefficient of a logarithm, so you can put it in the numerator. Not numerator, sorry, the exponent. So e to the natural log cancels out, so we're left with t plus 35 to the negative 3 halves. And then in my brackets, sorry, this is different. Same thing that's going to cancel out. You're just going to have the integral, though, of 6t plus 30, get out of here, 35 to the 1 half. Just double checking my math there. 3 halves. Sorry, I'm thinking ahead. 3 halves, right? Because this is going to be 3 halves power. So that cancels out. Okay, now I've got it. So we need to evaluate that integral. When we evaluate an integral, the power goes up by 1, so that's going to be 5 halves. We need to multiply it by the reciprocal, though, so that's 2/5 t plus 35 to the 5 halves. plus that arbitrary constant c, and that's all being multiplied by t plus 35 to the negative 3 halves on the outside. So when you distribute, the 5 halves plus the negative 3 halves is going to make a power of 1. And that's 12 over 5 here. So when we distribute, that's 12 over 5, t plus 35 to the 1 power. 12 over 5 t plus 35 to the first power. And then we can distribute this to this arbitrary constant c. So we're going to have this times that arbitrary constant c. We got t plus 35 to the negative 3 halves times that arbitrary constant c. So we got our function. We need to know what the arbitrary constant c is, and then once you've solved for that algebraically, you'll be able to plug in t equals 16. So this is our y of t. What you need to do next is plug in the fact that at time t equals 0, I think y is the amount of saline. Yeah, so you want to do 140 times 0.2, so what is that? That's 28. So plug in this initial value information to solve for c. And then once you have c, plug in t equals 16, and then we're done. Then we've solved the problem.